Hey everybody, welcome back. So we're back working with our sampler today. I did a video pretty recently on making a sampler with the wave object. If you haven't seen that, I recommend watching that one before you watch this one. The link is up above. And today what we're going to talk about is something that some of you mentioned in the comments, which is basically how to swap samples in and out of the sampler. There's going to be a lot more videos on this in the future. I really appreciate all the cool ideas that you all had in the comments of the other videos, stuff like MC, making this thing in Gen. So we're going to do all of those things because there's just tons and tons of terrain here in sampling. But today we'll talk about something that's perhaps a little more prosaic, which is just getting samplers in and out. In this one, there's going to be kind of a lot of patching that's like just working with data, managing things like lists, managing file names, things like that. So if you're new to max patching, this can be actually a useful video to watch because it will explain how to kind of work with some of the plumbing that is necessary in any max patch. Perhaps not the most fun part of max patching, but certainly a necessary part. Okay, so quickly let's go back over the anatomy of this patch. We won't spend a ton of time on it, but we have a buffer and the sound file lives inside the buffer. We have a waveform object that's visualizing that sound. And then we have a wave object down here that's playing back that sound. And you can see that we're just, with all of these objects that need to know what's inside the buffer, the wave, the waveform, the info over here, we just use the name of the buffer to refer back to that buffer. The wave plays it, and it does so with a signal that is a ramp. So we can see here, there's like a ramp that is some value between 0 and 1. And the slope of that ramp is, and also the length of it, is determined by basically this selection that we make on the waveform. And there's kind of three pieces of information that are important. So one is, what is the length of that selection in milliseconds, which we pass into a ramp object to generate a ramp from 0 to 1 that is that long. And then next is this section, where we actually scale that ramp to the length of the selection on a 0 to 1 range. Sorry, that's here. And then we offset it to also on a 0 to 1 range, so that rather than a ramp from 0 to 1, we get a ramp from 0.246 to 0.422. We could do a similar thing here with the scale object if we wanted to, but this is a cool way to do it. We're just scaling our 0 to 1 ramp by 0.422, and then we're adding 0.246. So if we want to play another file, the easiest way probably to do that would simply be to just load a different file into the buffer, right? So I can send a message replace Anton.aaf, which is another sample that's shipped by default with Max. So I click that and it loaded in. And this works great. So if I play, I'm not playing that. You can see that the selection window is a little bit off because we loaded in a sample that's a different length, but you know, that still works. In some situations, this may be totally fine, particularly if you're working with samples that aren't very long. But most of the time this can run into problems basically because it takes some time for that sample to load in. What you can do instead is basically just create a separate buffer and handle the loading of the sample in when your patch loads, right? So when your patch is opened, all of the buffers fill up with the sounds that should be inside of them. And then simply we'll just change the reference of all of these different objects to a different buffer. So I could send a message like set my sound to the wave object. And I'm playing now I have to reset my original buffer. So we're playing this sound. If I now go back to set my sound, which is the original buffer, then we get this. So that's basically the approach. We now have to connect all of the rest of the things here so that when we refer to this other buffer, we are changing the sample lengths and start points, and also changing the waveform viewer. So what I'm going to do is start off by just creating a menu. I'm going to say append my sound and append my sound 2. So we're going to send 2 messages into the menu. There we go. And now I can construct a set message for the wave tilde object. And info also wants the same message. So I can send set, and that will change the buffer that it refers to. For waveform, though, it wants buffer name. Cool. So now I can change that, and you can see it's changing in the waveform back and forth. We're changing it inside the wave object, and we're changing it inside the info object. The thing, though, is it doesn't, unfortunately, the waveform, or the info object, rather, is not triggered to output the length of the file when the reference changes. So we also need to send a bang into info. So what I'm going to do is this. So we're going to send a set message and a bang to the info and just the set message to wave. So now if I change the file, or the buffer reference rather, you can see that we're getting a different value out of the length outlet of info. But this stuff is not being updated. So we need to make some changes inside of this patch in order to get that changed length to actually do something. So let's open that up. Oops. Hello. There we go. So first, let's add a TBF in here because we get this buffer length in, and we are basically dividing the selection start and selection end points in milliseconds by that length in milliseconds to get these normalized coordinates on a range of 0 to 1. So we're just going to add a TBF, and we'll just fire every time we get a new buffer length. We're going to pass the value into the right inlet of these 2 division objects, and then we'll send bangs in to force the object to actually output something. So now you see if I change that sample reference, you can see that these 2 number boxes are changing. But the rightmost one isn't, and that's because with that one, we're simply getting the length of the selection here in milliseconds by subtracting the selection start from the selection end. So what we'll need to do here is either just tell the waveform object, hey, re-output a new selection start and selection end based on this new file with a new length, or just set the selection start and selection endpoints to, I don't know, the beginning and end of this new file. So we could kind of do it either way. I think it's probably a little bit easier to just set them to the beginning and end. So let's do that. So let's start off by using a trigger object here, because anytime that we have multiple patch cords coming from a single outlet, we want to think at least about using trigger, because it's very useful in being able to control event order. So in this particular case, I think we're going to want to update the view first, and then we don't really care about the other 2. And the reason that we want to update the view first is because what we're going to do is first update the view, and then the length that we get here from the info tilde object, we're going to then use to change the range that this waveform has selected. So we'll send a message which is going to be 0 and then the length of the file, and we'll send that into the 3rd inlet of the waveform object. So it says selection start ms, or if I do a list, that's going to be the selection start and the selection end. And then that should then get output from the outlets down here and then flow into this patch, and we should then see this value change. Let's see if it worked. Great. So when we change the file, we set the selection to the whole range of the file, and that got output. Okay, let's test it now. Also, let's change our envelope to be a little bit longer so that we can hear more of it. 1 second. There we go. And then if I change. Sorry, that's a little bit loud and screechy, but you can see what happened. It's happening there, right? We're getting all the information that we need updated. We're getting the view updated. Of course, you can then make a selection if you want to. So that's all working nicely. Now, the one last thing that I'm going to add here is there is a solution for how to have many sound files in many different buffers without having to have like a million different buffer objects all over your patch. It also has some other useful features, which is that it will make it very easy for you to do things like fill this type of umenu. So this object is called polybuffer, and I have to give it a name. And if I go to the help patch for this, and I just actually double click this polybuffer, you can see that we're getting this window that says drop a folder or a sound file. If I pass this read folder message, which is actually, I think, a default folder within Max, and then I double click it, then you can see that we have, in fact, all of Max's kind of built-in samples have been loaded into this buffer. So this is kind of a useful feature. If you have a folder that is full of all of the samples that you know that you're going to want to use with this sampler, then you can simply send read folder followed by the name of that folder, or you can just send read folder and it will open up a browser window for you and load all of those files in. You can also add your files one by one by sending an append message. So if I were to say append anton.aif, and then I double click this, then you can see that anton.aif is actually both the first one and the last one because I added it again to the end. So actually what I'll do is just borrow this right here and we'll just use this. So I'll do a load mess, and I will just copy the contents of that message box, and then we'll just send as a load mess. We'll send that right in. So if I double click this now and then I open, you can see we have those files loaded. When I load files, and actually I wonder if I double click this again, nice. So I didn't have to clear it. It's kind of cool. Like if I do read folder, it's going to just erase the contents of the polybuffer and then fill it with the new items. If I were to do like append, if I were to do like a load bang, and then I did like append anton.aaf, append cherokee.aaf, and I sent this, and then I send it again, it's just going to add them to the end. So if I ever want to do something like this where I use a bunch of appends, then I have to clear it first, unless I really want to just add them to the end. You see, so I clear and then send. But anyway, so in this case, we'll just use this folder approach to initialize the polybuffer. And you see that when I send that message, I get a bang from the right outlet. And that's useful because we can use it to trigger this get buffer list message. And when we send that, what it's going to do is produce for us a list of all of the sample buffer names. If I double click here, you can see we have all these samples loaded, and they each have unique buffer names, which are pretty transparent. Just the name of the polybuffer, a dot, and then some index. So what we can then do here is use this to fill the menu. So I could say root buffer list, and then select done so that we don't put done into the menu. And we'll also want to make sure that we clear the menu before we fill it. So when we have this bang that comes in, or this get buffer list message rather. We're going to send a clear first into the umenu. Let me organize things a little bit here. By the way, Command Y to do that. Segmented patch cord. Cool. And then we will just prepend append. So from the right outlet of select, we're going to get the name of the buffer. So we'll say prepend append. And so now if I say load mess, now I've loaded those in. And then additionally, what we can actually do is use this done to just have it select for us the first item. So we'll just send a message of 0 into the umenu when the reading is done so that we select by default the first item. And then we can simply pass that into this thing that we have here. And let's encapsulate some stuff. So to start, all of this would be nice to encapsulate. So we'll call this buffers. And by default, it should just get filled, right? If you want to see them, we could add an inlet and we could do like, we could have a message like view. And then we can use that to just send a message into the polybuffer that tells it to open the polybuffers window. So now if I come over here and I say view, then we're going to get that window. You can see here that I'm sending like W close comma open. You might be able to get away with just sending open here, but this is something I get in the habit of doing, just because if there's a window already open, it's going to make sure that that window gets closed and then that a new one gets opened, which just ensures for you that the contents that you're seeing in that window are actually the latest contents, which is an issue that happens particularly with the call object. So if you ever have like a thing like this where you want to open a new window of the call object and see what's in there, you have to close the existing window first. So I always do this. It might not be necessary in this case, but it's just a good habit to get into when you're patching. Cool. So now that has populated the menu and it's created this set of buffers for us. And now let's just do the part below the umenu. So I'm just going to grab all of this stuff. And I'm actually going to desegment the patch cords for a moment, just so that we can organize things. So we can include the info object in there. I'm going to take this my sound reference out because we don't need that anymore. And even this part too. And we can get rid of our old buffers. Okay, I think that that should be good. And we don't need this load bang either because we're going to bang the buffer, I believe, every time we change the file. Is that right? Yes. Okay, so let's just encapsulate all of this. Selected buffer. And we'll organize a little bit here. So I'm going to just put this up here. And I'll put this up here too. I'm going to clean this up a little bit before I share it with you all, but you get the idea, right? So we have a buffer section, we have the buffer menu where we select, and then we have all of these messages that have to go out elsewhere, flowing. And I just got rid of those load messes that were setting the start and end for the kind of default for the patch, because in this particular case, we don't really care about doing that because we're going, again, to be loading files in and just automatically setting that from within this selected buffer patch. And you can see here that this patch follows kind of this right to left order, which is just generally a smart thing to do when you're making subpatchers, to kind of follow Max's general rule of ordering events from right to left. The one exception being right here where, you know, the way that we have it structured, it will work that way. But if you want it to be really, really explicit and be like a really, you know, hygienic patcher, you would do something like this. All right. I believe that's all. Next time we'll get into more interesting stuff. I'm trying to decide whether to go into MC first and do an MC patch like this, or just go straight to gen and then do MC with gen, because we can always use mc.gen. Maybe I'll do that because it's just easier and less patching, boring patching. So yeah, stay tuned for that. See you soon. Bye.